Hi, I'm Reverend Greg and I welcome you to this video tutorial series Shaders for Hobby Programmers. This time we'll look into recreating Stans Coatby with a shader using GLFragCoord. As always, a short disclaimer, this tutorial series is mainly for hobby programmers who struggle with understanding shaders. I'm not a professional programmer and I'm not very good at maths. So if you see any mistake in my video or see a better way to solve a problem, please add a comment so everyone can learn from you. Now that we learned about GLFragCoord, I'd like to show an example shader which makes use of that. I'll just call it Stans Coatby shader because I immediately associate the effect with the coat of Stan in Monkey Island. For that one single viewer who doesn't know what I mean, Stan had a plaid coat, but no matter how he moved, the pattern did not move with him. Last video we learned that GLFragCoord is returning the position of the fragment in view space measured in pixels. So using this coordinate system helps us keeping the plate pattern in the same space of the view at all times instead of following the character. The first thing we're going to need are some sprites. For this effect to look nice, I need some sprites with rather large areas a plate pattern can be drawn in. I decided to go with a really nice CC0 sprite pack called Jumper Pack created by Kenney and published on OpenGameArt. If you're using the new base project, you'll find those in the assets, but I'll also leave a link in the description of this video. As background, I just stacked the layers of the sprite pack, added a platform from the pack and saved them in one single image file. I imported that new image and named it Sprite Jumper Pack Kenney BG. I also imported the bunny stand and ready images and created a 2-frame sprite which will be an idle animation and named the sprite Sprite Jumper Idle. And I imported the bunny's Walk 1 and Walk 2 images and created a 2-frame sprite from those and named it Sprite Jumper Walk. Now let's create an object by duplicating the template module of the base project and name it Object Stans Coatby. First, let's prepare some things not related to the shader per se, but for the base project. Inside the Create event, we can remove some code blocks. The information block, the resize block, and the scrolling mockup. The information is actually just for you to read if you want to use the base project. The resize is for scaling the view and the application surface. We're not going to do that. And scrolling mockups are an easy way to simulate a game for shader testing, but we're not going to use that this time. Then we'll change the info text. And this allows deselecting this module because we will only use one module anyways. We won't need the usual module sprite for this shader, so let's just remove that. And the shader we will name Shader Stans Coatby. Now to control and draw the bunny, I'll just use a new feature in the base project. We got several setup and movement scripts we can use to add a playable character to the game. One such pair is for a simple walk left-right movement, which we're going to use here. The script to set up this movement is called Script Setup Character Left-Right and takes an idle sprite, a walk right sprite and a mask sprite, which in our case is just the idle sprite. Since my background image only covers 1/3 of the view dimensions, I'm setting the image scale of our bunny to 3. Movement of 5 pixels per frame is about right and image speed I'll leave at 1. Now we'll need the shader uniforms. I want to be able to set the plate pattern's rectangle width, the width of the separation line and the color of the separation, so we need 3 uniform handlers. uGrid size, uSeparation width, and uCol separation. And we'll also need a color array to pass as the color of the separation. I'm picking a rather dark brownish color. And the new base project allows to set the caption of the sliders. One will be for the grid size and one for the separation, and since the slider values from 0 to 1 won't give us any useful information, I'll just turn off the drawing of those values. So I'll set caption of slider 0 to size, the caption of slider 1 to separation, and I'll turn off the value drawing. In step event, we need to add the character movement. Let's just delete everything here and set the description to move. Event inherited is just used to select or deselect a module, which we won't need since we're only going to use one module. And we won't use any scrolling mockup game this time. Now, since we set up the character in create event with a script setup character left right, we can now just use the movement script for the left right movement provided by the new base project. Script move character left right. Now, if you're not using the base project, all you really need is a sprite to move across the screen. So the simplest way to do this is to draw a sprite at mouse X and mouse Y coordinates instead of creating a walking bunny like I'll do in this video. Now in draw event, we'll need to prepare the uniforms. In the new base project, we can get the slider's value with a function called sliderGetValue and passing the slider number. Slider 0 will be the first created slider instance and slider 1 the second. The way the room template is set up, the sliders are created from top to bottom, so the uppermost slider is slider 0. We'll need a variable grid size and a variable separation width. Now for those who don't use the base project, the sliders I'm using return values from 0 to 1. So either create a slider or tween yourself or just set constants here. The grid size is in pixels and I set it to something from 0 to 150 pixels. The separation width will be a percentage of the grid width, so I'll set it to range from 0 to 1. For now, let's just draw the bunny as it is by the shader. So draw self. But we'll also need to pass the uniforms, the grid size, the separation width, and the separation color. A separation color, I just passed the color array setup in create event. And here's another difference to the old base project. The old project drew the test module frame and title in the parent's draw end event. If we didn't want to have that drawn, we would override the draw end event with a blank draw end event of the child. In the new base project, the module is drawn with a script draw module. And since we don't need that here for this test, I'll just remove the line. Now the room. Let's create a child of the template room of our base project and call it room Stans Coat. If you haven't watched the video on the new base project, this might look confusing, but it's actually a pretty neat setup. We got several sliders, toggle buttons, trigger buttons, info text, and other stuff prepared already. If we don't need some of the buttons, we can just either delete them or simpler and safer, move a kill modifier object on top of them. The kill modifier will remove buttons and sliders on the first frame of the room. So let's activate the instance layer called modifiers. We will only need 2 sliders, so I'll stretch the kill modifier there upwards. We also won't need any trigger buttons, so I'll stretch the modifier down to get rid of those. But we will need 1 toggle button, so I'll move the right side of the modifier to the left a bit and move a spare kill modifier to delete every toggle button but 1 and the last 2 trigger buttons. Now for this test we can hide the tile set layer. And in the background layer, I just set the imported background image and stretch it. On the main layer, I'll just add 2 walls left and right to cage the bunny. And place the Stans Coat object so its center is sitting on the platform. And that's it for the room setup. Now let's open the shader. In the vertex shader we can safely remove InColor and VV-Color. The way I set up the shader we won't need it. However, if you want the separation color to be taken from the vertex color, you'd of course leave the vertex shader as it is. Then you wouldn't need a uniform for the separation color and just use VV-Color in the fragment shader instead. In the fragment shader we can remove VV-Color from the header and inside the main function. Then we need to grab the uniforms. So uniform float grid size, uniform float separation width, and uniform vec3 call separation. Now, as always, I split the glFrag color line. Now, how this is going to work is this. We'll create a simple algorithm to determine where to draw the plate pattern lines and then mix the result with the base color. To check if the fragment is on a line, we'll need two functions we haven't used yet in this tutorial series. At least I think we haven't. First, the step function. Step takes two values. The first value is the edge value. The second value is compared to the edge. If the second value is smaller than the edge, step returns 0. And if it's greater than or equal to the edge, step returns 1. So it's really a nice switch to set on and off based on the second value. In our example, if the edge value is 1.5 and the input value is 1.4 or 1.49, step returns 0. But if the input value is the same as the edge, 1.5 or higher, step returns 1. The second function to have a look at is the fract function. Fract returns the fractional part of a number. In our example, you see with the input value 0.53, fract returns just that, 0.53. However, 1.24 is returned as 0.24, and 2.78 is returned as 0.78. So similar to mod, this can be used to get a looping value. No matter how low or great a value is, the return value of fract will always be larger or equal to 0 and lower than 1. So this is the algorithm we can use to calculate a plate pattern. Float weight. Weight is step. Separation width, the fractional part of the GLFragCoord x divided by grid width. Times step separation width and the fractional part of GLFragCoord y divided by grid width. Let's visualize what this code does. This is our view with its fragment coordinates. On the y-axis, I also add fragCoord.x divided by grid width. Now at a grid width of 100, fragCoord.x divided by grid width will be the red line here. So at fragCoord 100, fragCoord divided by grid width is 1. At fragCoord 200, it's 2, and at fragCoord 300, it's 3. But if we only take the fractional part of that division, then the result will zigzag from 0 to 1. So at fragCoord.x 250, fragCoord.x divided by grid width is 2.5 and the fractional part is 0.5. Now we compare the fractional part with the separation width. So as long as the fractional part of fragCoord.x divided by grid width is smaller than the edge value, that's the separation width 0.2, step returns 0. Now the second line of our code does the same for fragCoord.y and multiplies the result with what we got in the first line. So everything that's colored green or cyan has a weight of 0, and everything that stayed black has a weight of 1. And this weight can be used to mix the separation color with the base color. BaseColor.RGB is a mix of call separation and BaseCol.RGB by the weight. So whenever weight is 0, the fragment will have the separation color, and whenever weight is 1, the fragment will have the base color. Now let's run this and see if the plate pattern works. The effect won't be masked yet though. Looks like the algorithm is working, And since we use GLFragCoord to draw the lines, we can move Bunny around without moving the lines. So the hardest part is done. Now on to the masking. For masking the effect, we need duplicates of the idle sprite and the walking sprite and add mask to the asset names. We're going to use those duplicates as masks for our plate pattern. Now we need to edit those new mask sprites. We need to keep every pixel where the plate pattern should be drawn and remove everything else. So with the wand tool and the tolerance slider and some erasing, I'm going to remove the belly, the eyes, the mouth, the dots and the inner color on the ears. I'll just fast forward this part. Now back to the Stans Coatby object. Create and step event can stay unchanged. But in draw event we just want the mask to be drawn by the shader. First let's determine which mask to draw, idle or walking. At the top where we set up the local vars, we'll create a new variable called mask sprite for this. To determine which mask to draw, we check if sprite index is sprite jumper idle. If it is, the mask sprite will be sprite jumper idle mask, and if not, the mask sprite will be sprite jumper right mask. Now to draw the base sprite without a shader and the mask by the shader, I'll just move the draw self line and paste it before setting the shader. This will draw the base sprite. And after setting the shader, I'll just draw the mask. Now let's run this again. So now we got the effect running on only those parts where we want to. And this is basically it. We got a Stans Coatby effect using GLFragCoord to draw the pattern. But now, just for fun and because we can, let's add another pattern. I want to add a dotted pattern instead of a grid, and I want to be able to switch from pattern to pattern with the toggle button we didn't apply a kill modifier on in the room editor. I'm going to add the pattern to the same shader and use a uniform and an if statement to tell the shader which pattern to use. In a finished game, however, I'd most likely rather have two separate shaders instead to avoid that if statement in the fragment shader. So in create event of the Stans Coatby object, I'll add another handler, uShape. I'd also like to change the separation color to a very bright color just because I can. And to label the toggle button, I'll use another script of the new base project file. Toggle set caption 00 shape. The first 0 is for the toggle group and the second 0 for the toggle button in that group. Since we only got one toggle button, it's going to be button 0 of toggle group 0. In draw event, we'll need another local var to grab the toggle button state. We can use yet another script of the new base project called toggle get state, which will return true or false, or in other words, because this is GameMaker Studio, it will return 1 or 0. Toggle get state 00. So we're grabbing the state of toggle button group 0, button 0. Now we can pass the uniform to the shader. Onto the fragment shader. Here we need to grab the uniform. Uniform float shape. And with an if statement, we tell the fragment shader which pattern to use. So if shape is 1, we'll use the grid algorithm. And else, we'll use the circle algorithm. vec2 center is 1.4 times the fractional part of glFragCoord.xy divided by grid width minus 0.5, and the weight is step separation width length center. In this algorithm, we first determine the center of the circle based on the fractional part of glFragCoord divided by the grid width again, but this time for x and y at the same time. So we'll get a vector to the center. To get the center of the pattern, we need to remove 0.5, and to compensate the size of the circle, we need to multiply the result by the square root of 2. Roughly 1.4 is good enough. Then the step's edge separation width is compared with the length of the center vector. So if the length is smaller than the separation width, weight will be 0, and else weight will be 1. Now we can run this one last time. As you can see, this looks nice too. And it looks nice animated as well. Winter fur, summer fur. Winter fur, summer fur. Winter fur, summer fur. I just love this. So that's it for this video. I hope you have as much fun with this shader as I do, and I hope you learned something new today. Next time we'll probably create a shader using in position, so the coordinate system based on room space instead of view space. Until next time.